of this mission. Sir, I want to understand from your observation, obviously, like Professor pointed out, they will study space radiation and the weather in deep space, and it will help us understand how future missions can look like for human beings, how sustained duration of stay on the moon can be. And Artemis II specifically carried CubeSats to study space radiation, to study the weather over there. As per your perspective, when we get that data, do you think that we will be able to realign ourselves as to how human beings can look at longer durations or sustained stay on the moon? Because when we look at the International Space Station, for example, the astronauts do face a lot of challenging health problems after a certain point of time. How will we be able to realign the human being per se, in order to make sure that we do have sustained stays on the moon? And I also want to understand, do you believe that this is something that we can overcome?
Yeah, see, again, it's a very, very important there will be some takeaways from this mission. For example, what you can ask, what is how much of helium-3 can we get on the Earth? Limited. We don't get too much because we have a magnetic shield around the Earth. Whereas on the moon, there is no magnetic shield. So the particles, nothing but emitted by the solar radiation, will get penetrated on the moon's regolith, and this is one of the very important advantages. Now, coming back to health related things, yes, we had a lot of worries when one of the missions where Sunita Williams was stuck in space for more than 300, nearly 400 days. Certainly, we had our own worries about the structure of the bone, how the muscular performance will be affected, all those things. Luckily, as one of the panelists said, of course, this is a short duration, 10-day mission, nothing will happen. But the question of radiation is always there. You cannot prevent, you cannot escape from the radiation that is coming from outer galaxies. And we have to be, that's why we have all the shield. We have our own dress to be made. And this is one important thing which we cannot escape. Of course, there's other problem of debris falling on the for example, ISS is the where you had cases where ISS has people, astronauts, they can clear away from any dangerous debris coming from outer space. But if it falls, one of the examples I have seen shown in the literature is that solar panel is damaged. As there was some risk recently that the debris may damage ISS, they steered the ISS safely towards a region of how to escape from the debris falling. This is a big problem today, even though we are not been able to solve. How do you clean up the space? How do you get rid of this? Question is cannot be answered today, though there have been some attempts. They are not successful. Hopefully, sometime we will have this environmental hazard in space, including the radiation, environmental hazard of the debris. Debris is one of the, for example, one of the satellites where I was closely associated was postponed by a minute. The launch was postponed by 1 minute. Why? Because there was a danger of debris coming and hitting our mission. So instead of 11 o'clock, it was shifted to 11:01. So these are all some of the dangers yet to be solved. Of course, there are amateurs, bigger space agencies constantly monitoring with a very powerful ground-based radars, ground-based, not only amateurs, huge radars with a diameter of almost 1,000 feet diameter of antenna. They can look at the particles. Today we have the danger of having more than 1 million pieces of debris, junk, more than 1 centimeter. It's an alarming number. A small piece of even 1 centimeter diameter, if it hits the spacecraft, there'll be dangerous consequences. So we have to learn a lot. We have to learn a lot. Of course, we have learned a lot from this, because from the landing site observation on the far side of the moon, future missions beyond the moon, if you want to go to other outer planets, we can think of, many people are thinking of establishing a space station on the moon itself, because the gravity of the moon is less. So launching from the moon surface needs less fuel. So that is one of the very important takeaways by visiting the other side of the moon. Why other side of the moon? Other side of the moon is expected to have a lot of ice buried in the other side, because less radiation of the sun, and future astronauts can have their colonies, or their own launch stations, where water can be easily extracted. Water can be extracted from the moon surface, because we had some very powerful radars on the moon, Chandrayaan 3, Chandrayaan 2 orbiter, which continues even today, which can penetrate to the surface of the moon, and they can discover the presence or the quantity of ice. Once this is confirmed, complemented by the available data today from this mission, we can confidently go for bigger and more advanced missions in the space. This is what I personally feel, and we have got enough data. We have to look at the data available in these 10 days, and landing site has been probably one of the important things we have to take care, because Chandrayaan 2, Chandrayaan 3 took a very, very careful descent and finally landed on the best possible with powerful, sensors. So one more dimension is given by these missions, by these sensors which are on the Artemis 2. Thank you.
Very valid points. Let me take that across to Group Captain Jha as well. Group Captain Jha, Dr. Raju pointed out some very valid points. Experts are now saying that the reason why they wanted to, look at the farther side of the moon with human eyes is because human eyes can observe a lot of things that cameras and, the systems cannot see. And they also want to do that because they want to use the moon for future missions deeper into space. This is something that is obviously looking at it at a very long term, but this is something that scientists can look forward to now that this mission has been very successful.
Before actually, answering you this question, I just wanted to add few things when we were talking of the radiations at the moon. Look, there are many types of radiations, mostly ionizing radiation that we are very, very worried of. And in space, over the surface of the moon, since moon doesn't have the atmosphere, so it cannot absorb or it cannot remove those charged particles, ionizing radiations coming into surface. There are various types of ionizing radiation that keeps on coming, and the most of all is the solar events. That solar event could be either solar flare, solar winds, solar storms, or mass rejections, CMD, that happens, keeps on happening every now and then. So those charged particles, mostly those are the proton particles that come there. It's very dangerous because it keeps on coming all the time. There is no shield against them, unlike what we have here on the earth. Here we have got the magnetic field and we have got the atmosphere as well. Magnetic field keeps on removing those particles to the another areas. There are two Von Allen belts into which these charged particles, they are kept at various altitudes above the earth's surface, so that doesn't hit us. That is one thing that happens, and that protection is not there on the lunar surface. Other than that, the continuous galactic cosmic radiation, that also keeps on coming, and 87% of those are very, very high energy protons and the alpha particles that keeps on coming there. So they are very, very damaging and people cannot sustain there in that. Besides, every small object, maybe stone, the meteorites, they keep on hitting lunar surface. lunar surface is full of the ditches and the craters. Because of these hits, it sustains from the cosmos.
Right.
So those things are there on the lunar surface. What is happening, and due to that, the main concern is the radiation and the lack of atmosphere. Now coming back to your question. Look, the back side of the moon that we don't see it there. Look, it's the same thing. What happens here? The surface that we see uh, is no significantly different from what is on the other side. Moon also keeps on rotating like Earth. Only problem here is that in Earth we have got 24 hours of the day and night. In at Moon it is about 14 days plus of the day and a night. That the equivalent that I'm talking of. It rotates very slowly. So on the further side of the moon also, the sunlight comes up there. Everything is there. Everything that we have on the facing side facing us is on the other side also. It's only that we don't see it because the rotation of the moon is at the same angle that it goes around. So we keep on seeing every side, the same side every time. Now, the extracting minerals, I suppose we are going to, to the troubled waters. Uh, Moon right now, for the billions of years that it has been there, it is in the absolute correct orbit, that it doesn't deviate anywhere. Suppose if we keep on extracting minerals and keep on bringing the valuable maybe elements or anything from there, if the weight of the moon decreases, what happens to the orbit stability that moon has? Uh, this is a question that the scientists will have to address. That to what extent, how much of the mass you can bring from the moon to the Earth, because the moment moon gets by few kg, it will not. But when you keep on extracting mineral for Earth's economic gain, then there is a concern whether the moon will remain in the same orbit, and if it loses orbit, whether it comes towards the earth or it goes away from the earth. In either case, it will be a big loss for the earth and the inhabitants here in this. So those things people have to see. But then colonizing moon is going to be a tough task. There is no doubt about it, because there is no air, there is no water in the region that you are going to be inhabiting. And even those waters, what has been found in the polar region, it's so contaminated by these radiations that you won't be able to drink it as such. You won't. This has to be processed many times to remove those particles, the charged particles. Otherwise, the person who drinks that contaminated radiated water, they are going to face it. They are going to have a problem. So scientifically, we keep on talking about this. There is a limitation right now, but maybe in future, when the technology advances further, maybe we may be able to process in such a way that lunar water could be used for some purpose, at least on the surface of the moon. Because living on the moon, every breath that you are going to take, that oxygen that you need, you have to carry from here, or the lunar the regolith that we have got, the so-called mud that we have, we call it regolith, that we have to extract the life supporting elements from that, and for that you need industry. So much of industry will have to be brought up on the moon before we start thinking of colonizing moon. But yes, short stay there is going to be there. As such, during the Apollo program, whether it was Apollo 11, 12, 13, of course, didn't land back. That had to come back. The landing had to be abandoned. But then from Apollo 11 on to about, I think, Apollo 18th, 17th, and 18th, they did land there. They spent there almost nearly 7 days or so. Various times, ending up to extending up to 7 days. They stayed there. So people can stay there, sustain there with the resources taken from Earth. and utilized there in that micro space of the capsules. So all these things are possible. We are looking with the dreamy eyes to the future, wherein there could be a situation when colonization may happen. There are many other things that scientists are thinking
Absolutely.
of the possibility.
Right. Group Captain Jha, I apologize for interrupting you, but I want a quick last word from Professor Ram Srivastav as well before we take a short commercial. Professor Srivastav, there's another significant aspect to this of a free return that everyone is talking about, because that's something that NASA is terming as fuel efficient. Has Artemis II mission been able to, utilize that free return technology or trajectory that they were talking about?
Okay, it's a controlled trajectory, or it is actually the use of Earth gravity to minimize the fuel consumption while returning. But it's also very risky. And actually speaking, to set our return capsule in the proper orbit is a perfect science. We will have to evaluate its speed, its orientation, its inclination from the Earth plane, and the place where it has to cross the Earth, because on the upper atmosphere of the Earth, if a particular angle is not chosen, then it will be reflected back in the space. So the open window of the atmosphere, its calculation, its estimation, and its penetration is very important. Then comes the problem at the time of entry, because of the friction, high temperature of near about 5,000 degrees Fahrenheit is developed. So in this mission, the outer cover was totally burned, and it was directed to flash over the Pacific Ocean. That is very, very interesting. Obviously, it's a new technology which they have developed and tested successfully. So I hope for the future mission, the data collected here will be very useful.
All right. I'd like to introduce Lieutenant General A.K. Bhatt, who's the DG ISPR. Thank you so much, sir, for taking out your time and for speaking to NewsX. But we are slipping into a short commercial. We'll come back right to you. I thank you, Group Captain Jha, Dr. Raju, and Professor Srivastav for taking out your time.